and then in this point you are adding money, and the money that you are adding here is 5,000. That's what they told us. He deposited 5,000 into this account, and this account, they're saying 5 years later he added an extra 4,000 into the savings account. So in here there's another money that was added, which is what? 4,000. Are you with me? All right, now this is not a problem. That is not a problem. So it's money being added. So I'll use an arrow to say you are adding money. You are adding money. Hello again, our most valued student. My name is Confident and welcome to our lesson. Today I thought of teaching, and I want to teach you on the calculations involving additional payments. So I just wanted to take some time and look at this slowly, just through one example, and then in the later end I'll do some videos where I'll look at some previous papers. So most of the time I approach my lessons through previous papers, but here I thought of maybe laying a bit of foundation. Hence I say this is a must watch. You need to watch this if you're doing your grade 11 financial maths, as well as a good foundation for your grade 12. Let's look at the calculations involving additional payments and how to approach these. Now, before I begin my lesson, I'll encourage you, if this is your first time coming in contact with this channel, I'll encourage you to subscribe. Just get time, look at the button below, subscribe, and ensure that the notification bell is turned on. This will help you so that every time I upload a video, YouTube does send you a notification. So such helps you to prepare for your studies. Remember, I did this channel the 24-minute lesson. This channel has you in mind. I had you in mind, and I was like, how can I assist you? By the way, my story is always simple. I struggled a lot with my mathematics, and during the early stages of my maths, I had a big challenge ahead of me when it came to numbers, mathematics. But you know what? I'm the same person who's teaching the subject today, because it is possible. No matter what obstacle you have in front of you concerning maths, trust me, it is possible. Hence, sometimes I teach this in such a way that's why I say it has you in mind. So I remember my struggles, and then I try to bring it in a simplified way so that you can also see the light at the end of the tunnel. So if you are benefiting from this channel, that's why I'm saying you need to subscribe. Ensure the notification bell is turned on, and also you can share this channel with your friends. But the key word I usually use, this channel is for the underdogs in maths. So if you feel like I'm struggling, or I consider myself an underdog, not the best among the best, believe me, you can rise from being an underdog to become the best of the best in maths. So if you are the underdog, this is for you. Hence the pace is much slower than the normal other channels where they just rush to the formulas and answers. So let's look at this. As I say, this is a calculation involving additional payments. And when we are talking about additional payments, how do you approach these in your financial maths? Let's look at this example just to bring everything into perspective. It says Ethan, I used this name because that's my second born, is my boy, he's called Ethan. So Ethan deposits 5,000 into a savings account. So we are depositing, okay, so it's money being added, and then it says 5 years later, okay, that's important, he added an extra 4,000 into the savings account. Hence, the topic is called additional payments, whereby initially there is a deposit, and then some time after there is another deposit that is added into. So let me repeat again. Ethan deposits 5,000 into a savings account. 5 years later, he added an extra 4,000 into the same savings account. The interest rate for the first 3 years is 12.5% per annum, compounded annually. So the compounding here is semi-annually. Thereafter, the interest rate changes to 14% per annum, compounded monthly. Calculate the future value of the savings at the end of the 7th year. So let's look at this. Very, very good information there that we can put into. Let's look at the time frame here that we can use. So let me just select this one with that. So let's say we have here the timeline, and in our timeline I've got the seventh year. So it's a 7-year period. So if I can have this and say this is my let me just do this. So to say this is my T1, T2, I might not be able to bring it into equal parts. So this is 1, 2, 3, 4, 5, 6, 7. Okay, so this is my timeline here. It's a 7-year timeline, and in this timeline they are telling us a few things here to say. Let me start from T0. So what I have here is the beginning, which is T0, and then there is T1, there is T2, then there is T3, meaning year 3, year 4, year 5, year 6, and the last year of this investment was year 7. So now let's go back to the statement. It says if then deposits. So when you're depositing, what do? You are adding money into an account. So this is at the beginning. So you start from T0 here, and then in this point you are adding money, and the money that you are adding here is 5,000. That's what they told us. He deposited 5,000 into this account, and this account, they're saying 5 years later he added an extra 4,000 into the savings account. So in here there's another money that was added, which is what? 4,000. Are you with me? All right, now this is not a problem. That is not a problem. So it's money being added. So I'll use an arrow to say you are adding money, you are adding money. But there comes the part. It says 5. Okay, it says the interest rate. That's where the confusion now comes. The interest rate for the first 3 years. Look at this now. There is a first 3 years is 12.5% per annum. So what are they saying? They are saying with this 5,000, if you go to year 1, year 2, and year 3 up to here, there is an interest rate of that is different. So if I can come here and say this 5,000 up to 3 years, there was an interest rate, and then it says 12.5% per annum. So if you remember, whenever you're given 12.5%, you need to convert it. So it's 12.5. You divide a percentage is what? Is over 100, which is 0.125. So here my interest is equal to 0.125. Now, if this is your first time watching this channel, that's why I said you need to subscribe. There are 2 videos I did previously where I cover some of the financial maths aspects. So I will encourage you to watch them so that you can understand what I'm doing here. Okay, so then they're saying compounded semi-annually. That's where the challenge is. The interest rate is different, the compounding is different. Now if they say semi-annually, this is half yearly, to say for every 6 months. Semi-annually, meaning for every 6 months the compounding, there is a compound for every 6 months. This interest rate is affected for every 6 months period. That's why they're saying compounded semi-annually. So now what does it mean? It means, as I say in my previous lesson, I will say my n is equal to 2. Why? Because there are 2 half years in a year. From January to June, that's the first half year, and then from July to December, that's the second half year. So in a year there are 2 half years. That's why my n there is equal to 2. I said my n with a star because it's not the number of years here, it's the number of compounding. Okay, so that is that. And then what are they saying? Then they are saying thereafter the interest rate changes to 14% per annum, compounded what? Monthly. That's where the trick is. Look at this. This 5,000 goes for year 1, year 2, year 3 on the same interest rate. But now they are saying after 5 years, am I right? 5 years later he added, no, not after 5 years. They are saying the interest rate for the first 3 years. Sorry about that. 3 years is that, and then says thereafter, which meaning from the 3rd year thereafter to what? To the 7th year, there is an interest rate, and what is that interest rate is now changing to 14%. So which means my I is equal to 14 over 100. As I said, you divide, which is 0.14. Are you with me? You are interested in that one, 0.14, just like you are interested in 0.125. And then what is the compounding? They're saying is 14% per annum compounded monthly. So how many months are there in a year? We are saying there is 12 months in a year. So my n there, the compounding is 12. But look now, pay attention. The 5,000 is the one that is moving from 0, that is 5,000, to T3, and then from T3 to T7. I have not included 4,000. Now, let's look at 4,000. So they're saying the 5,000, the first interest rate for 5,000 was I is 0.25. Then after 3 years, it became 0.14. But what about for 4,000? The same 4,000 here, it was deposited into the account, but now they are saying thereafter the interest rate changes to 14%. But now the good part about the 4,000 is that it was deposited in year 5. And in year 5 already, it was under the interest rate of 0.14. So if I use a different pen here, we will say this 4,000, it grew also to year 7, but it had a different, it was 4,000, it has the same interest rate, which is 0.14. That's your I is equal to 0.14. So you see what I just did? It is the simplest way you can approach that. I'm going to do it, as I said, I'm teaching here, I'm going to do it in different ways so that you can see how you can approach that. Now, how do you work this out? You work this out just like we did previously, to say our formula A is equal to P 1 plus I to the power n. This is compounding, compound interest formula. You need to know what you're doing here to say the question is calculate the future value. Obviously, they are looking for A, the accumulated amount. So our A is equal to, now since I've got two different amounts, the first one I'm going to calculate it in two parts. I have got again here A is equal to P 1 plus I to the power n. Look at this. The first one is my A for the 5,000. Are you seeing that? I'm just making it clear for you so that you don't confuse. So what happened to this 5,000? This 5,000 in the first year, it had what? It had a different interest rate. So my P is 5,000. You put a bracket, which is 1 plus my I. That's where the I is. It's 0.125. You see, then I said there is a compounding of n. That's where you divide by that 2. Then you close, you multiply, you put it to the power 2, and then multiply by the years. How many years here? From T1, this is 1, 2, 3 years. See? So you multiply that by 3 years. What is the 2? The 2 is the compounding, not the number of years. They said it was compounded semi-annually. That's the 2. So when you divide by 2, it's your exponent by 2. As I said, just check previous videos there. Very, very important concept. And then that is the first what? That's the first 3 years. We can use a calculator here to find the amount in the first 3 years. We are not yet in the other remainder of the years. So we are saying 5,000 bracket 1 plus 0.125 over 2, and then you multiply that to the power what? 2 times 3. Are you with me? Then it will give us this amount, which is 7193. It is good not to what I'll say, it is good not to round it off. You write it as is, but for the sake of because I can't write that long figure for me, I'll try to write as much as I can. It's 7193 Okay, let me write all of it. 7193.55. 55613. 7193.55619. I tried. I hope I did right. This is my first one. That's my A. Are you with me? But A, this is for the first 3 years, right? So you can even, I can even indicate here, this is 3 years. And then you continue again. A is equal to P1 plus I to the power n. Now we're looking for the remainder. Remember, it was the first 3 years. Then after that, from this year, it went to year 7 with a different interest rate and a different compounding. So I'll do the same thing to say A is equal to, but what is my P? You must understand that my new P is this amount here. This amount here is the one now that becomes my new amount that is there. Are you with me? So that's what I'm starting with now. My principal amount, or the starting value, is no longer 5,000, because after 3 years I no longer have 5,000 in the account. After 3 years I now have 7,193 rand 55 or 56 cents. So if I go to the bank after 3 years, this is the amount of money I will find. 7,193 rand. I won't find 5,000. So I'm going to take that 7,193 and grow it for the next how many years? From T3 to T7. That's 4 years. Are you with me? So this is 1, 2, 3, 4. So this is for the next 4 years with a different interest rate. So let's do it. My P is 7193, 56193 bracket 1 plus our I is where it changed. What is our I? 0,14. Seeing that? It's 0,14, but they told us what compounding? Monthly. That's why I'm dividing by n of 12 there. But remember, I said after that, close the bracket, you put to the power what? 12 and multiply by the number of years. There we go. We say it is 4 years. Then with that, you can then, I had that previous figure. So I hope I wrote it right. 719355616. It was not 6193, but it's fine. I still have it here. So I'm going to take that money, which is this one, and then say bracket. Okay, that's my answer equal to. So I still have this answer. So I'll say answer, which is my P, bracket 1 plus 0,14. I'll encourage you also to do the same calculations while I'm doing them here, just to check your answers. 12 times 4. Are you with me? Equal to, then you have got this amount, 12,552 rand 80.5. I mean 805. Let me round off to 2 decimal places. This is money. Is 12,552 rand 81 cent. 12,500. It's 12,552 rand 81 cent. So this is the what? The accumulated 5,000. This is good investment, eh? From 5,000, after 7 years, you've got 12,000. It's not bad. But are we done? No. We still have the 4,000 that was added into this account. Now we come back here to say, by the way, Ethan deposited an extra 4,000 in year 5 at T5. So you come here to say, for Ethan here, for the 4,000 he deposited, how much did it grow from T5 to T7? You can see this is 1, 2 years. So which means the 4,000 was in the bank for 2 years. So our P now is 4,000. This is also has got its own growth, which is 1 plus I. Remember, the interest rate didn't change for the two amounts, and then but the compounding was still 12, and then you multiply by 12. How many years left? It's 2 years. This, if you master it, it won't give you a problem. Then you do that. Put this together. 4,000 bracket 1 plus 0,14 over 12. Are you with me, guys? And then close, and then to the power 12 times 2. Okay, what do we have? I've got 5,283 rand 95. I told you how you can round off. Shift setup 6 to 2 decimal places. You see, it can give that 5,283 rand 95. 5,283 rand 95 cent. So this is the amount that 4,000 becomes after 2 years. But now the question is, calculate the future value of these savings. Obviously, I need to consider these two amounts. I cannot just leave it like that. I've got this amount and I've got this amount. So what do you think I must do? I must add them. I must add the accumulated amount of 5,000 plus the accumulated amount of what? Of the 4,000. I must add both. So I'm adding here the 12,552 rand 81 cent plus the 5,283 rand 95 cent. Then when I add that, it will then give me the total amount of this investment is 12,552.81 plus 5,283.95 then equal to 17,836 rand 76 cent. So 17,836 rand. I don't know, I forgot that one, but you can check that whether it was 76 here. I forgot the decimal, but look at this, it's 17,836 rand. I forgot the decimals there to 2 decimal places. So guys, do you see what we did here? Do you see, or what I did here? I can put this in a one line for you. Look what I did. I took the 5,000 and this statement here, let me start here. Okay, let me write it a bit far so that I can fit it. This thing can be done in one line. They can actually encourage you to write it in one line, to say A is equal to P. What was P? P was the 5,000 that we started with. You put a bracket and then you write that part, which is 1 plus 0,125 over 2 to the power 2 times 3. Let me show you that. This is the part I'm writing, this one here. So I wrote this, but now remember, we took this amount, this became that amount, and then we added this part. So again, you can actually add this part here that I'm writing. You can add now this. How do you add it? You also do the same and say bracket here 1 plus 0,14 over 12, and then is what? 12 times 4. Again, you are not done. We said there was the 4,000 that you added. Then you go and say plus 4,000 bracket 1 plus, it was the same compounding there, 0,14 over 12, and then it was 12 times 2 because it was for 2 years. You see this? So I'm writing that, I'm writing this, I'm writing that. I just put all this as one thing. And then if you test it with a calculator, just out of interest sake, let's test this. It's 5,000 bracket 1 plus 0,125. I needed to put that in a fraction. 0,125 over 2. You multiply that by what? You close that, and then I say to the power 2 times 3, right? And then play forward, open another bracket, which is 1 plus that 0,14 over 12. Seeing that? Are you seeing that, guys? And then to the power 12 times 4. Okay, and then play forward, I say plus this, actually I say 400, this is 4,000. 4,000 bracket 1 plus that, which is 0,14 over 12, and then to the power 12 times 2 equal to 17,836 rand 75 cents. So it's 17,836 rand 75 cents. 17,836 rand 75 cents is my A. Now if you remember, we got our A here being 17,836 rand. I said 75. No, you can have one or two because of rounding off here errors that pick up, but look at the answer, it's the same thing. All right, but now it's still an interesting statement here, which we can still do in other forms. In other forms, if you want to. This is still something that can be done in other forms. If you say, but I'm still not a bit comfortable with your approach, let me do this. I just don't want to write everything anew. Look at this. We can still argue and say, let me see the other approach. To say you have 5,000 here. Okay, you start with 5,000. Now they say it for how many years? They say it for 3 years. So 5,000. Ethan deposited 5,000 in savings account. 5 years later, I added that into the savings account. The interest rate for the first 3 years. So we say take this to the first 3 years. Remember, the interest is 0,125. That's our I here. And then our compounding is semi-annually, which is 2. You have got that. Are you with me? Then here, after that, grow. So this money, you grow this money up to T3. Then the interest rate changes here. You take that money that would have been and you grow it until T5 with interest rate of 0,14. Don't forget now, they told us to say the interest thereafter the interest rate changes to 14% per annum, compounded what? Monthly. Are you with me? 5 years later, I added that. The interest rate for the first 3 years, for 3 years is that. Then thereafter, meaning after 3 years. So after 3 years, the interest rate, our N is now 12. Are you seeing that? Then, why am I going to T5? Because here, there was an extra money added, which was 4,000. Let me use a different marker here. There is an extra money that is added. And this extra money that is added here is what? Here, we add an extra amount. That extra amount is 4,000. Are you with me? Now, if you add the 4,000, we are going now to find a new total here, which we're then going to grow up to the end. Don't forget, our I will still be 0,14, and then our N is equal to 12. Let's try that. I think we can still reach the same answer. I did it. The good thing is the answer is still there. So let's try that. What am I saying? Take this A is equal to P1 plus I to the power of N. You see that? And then start with the first one, 5,000. Right? And then you've got 1 plus I, 0,125 over 2, because they said same annually. You put that 2 again as an exponent. Then you multiply by the years in here. From this to this, it's 3 years. So you multiply by 3. Okay, then I'm going to find the answer here. But as I said, it's not okay. I can find the answer here to say this answer becomes, let me just bring in the calculator here. It becomes 5,000. All right, bracket 1 plus 0,125 over 2. That you multiply by 2 times what? 3. Are you with me? Equal to, I can get that amount, which is 7193,55. So when I take, I hope I did that, is 5,000. So 7193,56. 7193,56. So it's 7193,56. I'm rounding off, so the answers will differ a little bit on the decimal side. So there will be always a small difference there. Then from here, what do? I take again, pay attention, I take this money, which is here now. So this money now is here. After 3 years, when you go to the bank, you're going to find what? So if I say A is equal to P 1 plus I to the power of n. So what is my accumulated 5,000? Now, when I go to the bank after 3 years, I'm going to find the new P, which is 7193. We talked about this, comma 56. Bracket 1 plus I is the new I now, 0.14 over 12. The moment you say divided by 12, you multiply by 12. But how many years? From T3 to T5, where they deposited the new 4,000, it's how many years here? It's 2 years. So T3, T4, T5. So you multiply by 2. I get that amount. It will give me the money that will be in the account before Ethan deposits what? Before Ethan deposit that 4,000. So I'll say 7193, comma 56, put a bracket, and then I've got 1 plus, put that 0.14, and then divide by 12, and then close the bracket, and then multiply what? We're going to multiply to the power of 12 times 2. Are you with me? Equal to, then I get this. Now, see, the money now that is in the account after 5 years is 9,502 rand, 59.99, which is 60. 5902, 5902, 9502, 9502.60. This is the amount of money that is now in the account. This amount A, this amount is the money that is here now. When you go here, that's the money that is there. When you go to the account, before he puts this 4,000, he's going to discover that he has got now what? 9,502 rand that. So it's as if you add that 9,502 rand 60. So you must add those two amounts. To say at T5, let me erase here. To say at T5, he has got what? 9,502 rand 60, but he added what? He deposited 4,000, remember? So how much does he have in total? That's the money that we're going to invest into the next future gain. So it's 9,502.60 plus 4K equal to, what do I get? 13,502 rand 6 cents. So it's 13,502 rand 60. This is the amount you're going to find him having. Let's say he stopped at T5. That's the amount you're going to have. The 4,000 in the hand plus this 9,500. But he didn't do that. He left it to grow for the next 2 years. Remember, he wanted to take his money at T7. So Ethan leaves their money from T5 to T7. How many years is that? He leaves it for the next 2 years at that interest with the monthly compounding. So what do? You do the same thing to say here A is equal to P 1 plus I to the power of n, and then A is equal to the P there is what? 13,502 rand 60. Right, bracket 1 plus, what's the compounding? It was 0.14. Then we divided that by 12. We said 2 years left. You put that 12 multiplied by the number of years, which is what? Which is 2. Then we do that to say what is our A. Guys, it must give us the same answer now. 13,502.60 bracket 1 plus 0.14 over 12, and then to the power of 12 times 2. Alright, equal to 17,836 rand 76 cents. 17,836. 17,836 rand 76 cents. This is the money that he's having. Compare this, I think it's the same actually. See? 17,836 rand 76 cents. It was almost the same, different from this one by 75 here. Guys, it's the approach. It's the same thing, just the approach that you decide. Either you do whereby you take the 5,000, take the 5,000 into T5, add the 4,000, the one that I just did, or you allow the 5,000 to grow until the end, and then allow the 4,000 to grow until the end, and then you bring those monies together. That is the approach which, when you talk about additional payments, you can approach two ways: the first one and the second one. Which one do you think is best? Give me your comments. But in any way, just be sensitive. The key part here is that they change the interest rate and they change the compounding. So you need to be sensitive to that. And it's not really complicated, but you need to follow up with the timelines. The timelines can actually assist you. So guys, we have come to the end of our lesson, where I was bringing this to you so that you can be able to understand additional payments. Now, in the next lesson, I'm going to focus on payments that involves also withdrawals. You are investing money, for example, that is me here. Confident deposits a birthday gift of 14,000 into a savings account in order to save up for an overseas trip in 6 years' time. At the end of the second year, some things something come up, some things, whatever case comes up, and he withdraws 2,000. No, what we can say, life happens, and I withdraw, because it's me here, I withdraw 2,000 from the account. You see, I am depositing in the beginning, I'm investing, so this money is growing, but 2 years, something come up, some things come up. I think that's what I wanted to say. Some things come up, and then I withdraw 2,000, but there's still some money left. That money that is left must also grow. How much money will he have saved at the end of the 6-year period, assuming that the interest rate for the whole period is what? 8% per annum compounded monthly. I'm going to show you how to approach this. So tune in the next lesson. What is the best way to do? Subscribe, guys. If you have subscribed and the notification bell is turned on, you're not gonna lose this. Remember, this is towards your exams, so you need to be having these videos always reminding you to watch. I mean, it's few minutes videos you watch, then after that you practice. Don't just watch and practice. And remember, I have this channel with you in mind. Give me your comments, share the channel with your friends and colleagues. I have come to the end of the lesson. Thank you.